Example, find the transformation which maps outside the modulus z equals to 1 on the half plane real of w is greater than equal to 0, so that the points z equals to 1 minus iota minus 1 correspond to w equals to iota 0 and minus iota. Solution: clearly the points z equals to 1 minus iota minus 1 lie on the circle modulus z equals to 1, and the points w equals to iota 0 minus iota lie on the imaginary axis of the w plane. The required transformation is such that the points z1 minus iota minus 1 respectively are transformed into the points w iota 0 minus iota. Because the cross ratio is preserved under the bilinear transformation, so w iota 0 and minus iota equals to z1 minus iota minus 1, which implies w minus 1 into 0 plus iota w minus iota into 0 plus iota upon iota minus 0 into minus iota minus w equals to z minus 1 into minus iota plus 1 upon 1 plus iota into 1 minus z, which employs iota into w minus iota upon minus iota into w plus iota equals to 1 minus iota into z minus 1 upon minus into 1 plus iota into z plus iota and z plus 1, which implies w minus iota upon w plus iota equals to minus iota into z plus 1 upon z plus 1, which implies w minus iota over w plus iota equals to 1 z plus iota over z plus iota, because 1 minus iota over 1 plus iota equals to minus iota. Applying the componendo and dividendo, we get w minus iota plus w plus iota upon w minus iota minus w minus iota equals to iota z plus z plus 1 upon minus iota z plus iota minus z minus 1 employs 2w upon minus 2 iota equals to z into 1 minus iota plus 1 plus iota upon minus into z into 1 plus iota plus 1 minus iota, which employs w equals to 1 minus iota into z plus 1 plus iota upon 1 minus iota upon 1 plus iota into z plus 1 minus iota upon 1 plus iota, which employs w equals to iota into minus iota into z plus iota over z minus iota. Which employs w equals to z plus iota over z minus iota, because 1 plus iota over 1 plus iota equals to minus iota, which employs wz minus 1 wz minus iota w equals to z plus iota, which implies w minus 1 into z equals to iota into w plus 1, which implies z equals to iota into w plus 1 upon w minus 1. Under this transformation, modulus z equal greater than equals to 1 is transformed into modulus iota w plus 1 upon w plus 1 is greater than equal to 1, that is modulus w plus 1 upon modulus w minus 1 is greater than equal to 1, because modulus iota equals to 1, that is w modulus w plus 1 is greater than modulus w minus 1, that is modulus w plus 1 square is greater than equal to modulus w minus 1 square, that is w plus 1 into w bar plus 1 is greater than equal to w minus 1 into w bar minus 1, and that is w into w bar plus w bar plus 1 is greater than equal to w into w bar minus w into w bar plus 1, that is 2 into w plus w bar greater than equal to 0, that is 2 into 2u is greater than equal to 0, that is u is greater than equal to 0, that is real of w is greater than equal to 0. So the modulus z is greater than equal to g is the transformed into real of w is greater than equal to 0 under the transformation. So w equals to z plus iota over z minus iota, which is the required bilinear transformation.